this side of the battery to this side of the battery. Can everybody show me this side of the battery? Point your laser at this side of the battery. Closer, closer. And it wants to get to this side, but it doesn't have a way to get there to that side of the battery. So we want to provide a path for our electricity. And we can use resistors, but you know what? It still doesn't make it around, and so electricity can't flow through my battery. So we need more. Does anybody know what this is? Anybody? 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 A light. It's not quite a light bulb, but you can call it a light bulb. This is an LED. It's a light emitting diode. And this is the symbol for a diode on here. It's a triangle. It tells us that electricity only goes in one direction. Can anybody guess what direction the electricity goes? Now, the arrow points the way. Now, what's really funny is I learned that electricity goes the other way. And it really confused me when I saw these symbols, because I was like, but that doesn't really matter. Electricity flows, and we're going to learn that electricity goes in the direction of the arrow. Okay, so if electricity goes in the direction of the arrow, can electricity start flowing? Is my light on? No, why not? What's missing?
The battery.
The battery. The battery's right here. What's missing? All right. So we call this a circuit, except this circuit is open. All right. This circuit doesn't have a way for electricity to flow, but when I connect it all together, my electricity flows. Now show me the direction the electricity is flowing. Which way is it going? Where's the electrons? Where are the electrons coming from? Where are they going? All right. So show me that circle. Excellent, excellent. All right. So those are my electrons flowing through my circuit. All right. Now, what is this piece called? A resistor. Excellent. And what does this thing do? What does a resistor do? It slows it down. It uses up some of the electricity. What if the resistor wasn't there and the circuit was still completed? What would we have? What would happen if we didn't use up some of the electricity in my resistor? Where would it go? Let's take a look. All right, so I'm going to take the resistor out. Is the light brighter? Yeah, so what does the resistor do? It uses up some of that electricity. All right, so that is that component. Now, this component here, what is this called? Anybody know? Anybody ever watch the movie Back to the Future? Back to the Future, there was a special thing inside. It was called the flux capacitor. Now, this is not a flux capacitor. This is just a regular capacitor. So, don't worry, there will be no time travel in today's little talk. But a capacitor is kind of like a battery. It stores electricity up, right? And we like to store electricity. Why do we like to store electricity? Why do you like to store electricity? So you can use it to use your microwave. We don't normally use batteries in our microwave, but we do use some capacitors in our microwave. That's good. Young lady, why do you like to store electricity in batteries? Look at your hands. So you can use your devices, your phones, your iPods, all of those things, they need batteries, and we have to store electricity inside of batteries. Now, is a capacitor a battery? Sort of. It stores electricity in it, but it wants to let it go really, really fast, okay? Your battery lets it out kind of slow. And a capacitor, it's just like, hey, you want it, here you go, gives it all back in as fast as it can. But have you ever had an extension cord that was too short, and you were trying to plug it into something, and it just wouldn't go, right? So look at this schematic symbol here. It's kind of like the wire is coming across this way, and then it stops. And it's coming from this way, and it stops over here on this side too. So it's not directly connected. It's like there's a big plate of metal on one side and a big plate of metal on the other side, and they want to let the electricity through. They really, really do, but they're so close they just can't get across. So they can feel it. When you put a bunch of electrons on one side of a capacitor, the other side feels it, and they're kind of pulled that way, but they just can't jump across. All right. So it's kind of like a battery, but it stores up electricity. But when I put electrons on one side and they're all pulled to this side, I can switch it and then pull electrons onto the other side, and then they kind of flip-flop to the other side. And I can do that back and forth really fast. The capacitors can feel it, so they like alternating current electricity. alternating current electricity we say can flow through a capacitor because it feels it, and because the electrons don't really travel very far in alternating current electricity. Wait a minute. Wait a minute. Can we have an electron race? Can you step up here? I'm going to pretend to be an electron, and we're going to race to that wall over there, okay? And then we're going to turn around and come back, all right? But you're going to be you, and I'm going to travel at the speed of an electron and a piece of wire, all right? On your marks. Get set. Go! Hey! Alright, so electrons are pretty slow. When you turn the electrons on, if we use DC electricity, you can go on back. Thank you very much. If you use DC electricity, before the electron in the light switch got to the light, you could walk to the light and unscrew it. But here's the thing. One, we don't use DC electricity, we use alternating current electricity. And the other part of it is that the electrons don't have to get from the light switch to the light. Have you ever seen a hose? And when you turn the water on in the hose, water comes into the hose on this end. And then you wait for the water to go all the way through the hose, and then it comes out the other end, right? But if I turn the water off, and I leave the water in the hose, what happens the next time I turn the hose on? A little water comes in this side, but then water immediately pops out the other side, right? So the water doesn't have to travel all the way through the hose, it just pushes the water that's already in the hose out. Well, that's what happens in electricity. There are electrons already in the wire. What kind of wire? Like copper wire. It has lots of electrons in it, and they're easy to push out. So it doesn't really even matter, because there are lots of electrons ready to go inside of our wire, in our capacitor, to be pushed around. But the transistor, this is the thing that makes it all happen, ladies and gentlemen. This is the thing that makes our oscillations possible, because this is like a light switch. Do you guys ever have light switches that you turn on and off? Do you have the little dimmers on them that you turn on and off? Well, this guy acts kind of like that dimmer, except instead of you having to move the switch, it's got this little transistor, and you can move the dimmer up and down just with electricity. The more electricity that you put on this thing, the brighter you can make your light. And so for us, we want to connect our circuit through our transistor. And we have a chance at getting it right and getting it wrong. So here, electricity can't flow. My transistor, it's called a transfer resistor is where it got its name. And it acts like a great big resistor right here, right? We know what happens if I put a big resistor in the circuit, the light's not very bright. And if I put a huge resistor, well, the light doesn't even come on at all. So this is acting like a huge resistor right now. But if I put a little bit of electricity between this point and this point, my light turns on kind of dimly. Because this side of the transistor controls how much resistance I have on that side. So if I add less resistance, if I have more electricity here, I'll get less resistance and my light will turn on brighter. So if I lift my fingers, well, first without, kind of dim, and I lift my fingers, and it gets a little bit brighter, okay? So that's a transistor. And this transistor, it turns on super fast, okay? So fast, as a matter of fact, we're going to be able to make a radio. But one of the things we're going to get to before that is we want to talk about what oscillations are and what they do. So this is sometimes called a useless machine. This gold box, what happens is there's a switch here, and sometimes my switch is ready and sometimes it's not, but we'll see. But when I turn this on, my useless machine is going to turn itself off. That's all that it does. I mean, that's pretty useless. You turn the machine on, and it just turns itself off. Not very useful. But this is kind of interesting. If I have two useless machines, and I put them together, when I turn one useless machine on, he says, and then the other useless machine's like, hey, don't turn me on. And then the other useless machine's like, wait a minute, what are you doing? And this is called oscillation. It goes back and forth. And there are things we can do to control how fast my useless machine works. We can turn our useless machine off by saying, stop! And then it'll stop. Alright, so how do we control the speed of the useless machine? Does everybody remember our pendulum? What controls the speed of my pendulum? The length of the string, right? So this is a physical property. Does everybody remember how we control the lights in the kitchen with the dimmer switch? That's a physical motion. Well, we're talking electronics here. Do we like physical motion, physical movement? No, what do? We change the amount of electricity on a transistor to get the change that we want. And so that's what we're going to do in this oscillator over here. Now, do I have anybody that studied electronics? Does anybody recognize this circuit? All right, one person, no pressure, no pressure. Just say JK flip-flop. Do you know what kind of circuit this is? All right, we'll call this, sometimes this is called a JK flip-flop or an astable multi-vibrator. It's astable, that means it's not stable in any state. If I have one of these, it's monostable. It's only happy when it's off. And if I turn it on, what does it do? What does it do when I turn it on? It plays with an iPhone, I'm guessing. It turns itself off, all right? So this one is astable. It keeps going back and forth until the batteries die. So, what controls how fast this circuit turns on and off? It flips back and forth. Does anybody have any guesses? Say it louder. What are you saying? Okay, so we've got a couple of choices. We've got resistors here, and we've got a capacitor. Capacitors charge up, they act like batteries. So in this circuit, our capacitor is going to squirt some electricity, and it's connected to this transistor. And it's going to turn this transistor on or off. And when this one turns off, it turns the other one on. And when that one turns on, it charges the capacitor on the other side. It turns the other one off, it turns the other one on, and back and forth, and back and forth. And by changing the value of this capacitor, or this resistor here, we can change the frequency that this circuit oscillates at. And this circuit here, is this really fast or is this kind of slow? It's kind of slow, all right? Now, is a radio kind of fast or kind of slow?